Hi students, it's Dr. Marks, and I'm making this video for you so that you can understand what you need to do when being asked to compare subgroups in regression. This is something that we do often, and while we can make it a lot more sophisticated, there's a very easy way to do this. So sometimes we want to know if an explanatory variable has the same impact when looking at different subgroups. Maybe you have a large data set and there's different ways to slice and dice that data set into smaller groups, and maybe your variables have different impacts depending on what subgroup you're looking at. So for example, does the number of absences impact test scores of my college students similarly? So maybe I want to know, does the number of absence my students have any impact on their test scores? Well, probably it does, right? But what about when I'm comparing stronger and weaker students? Maybe we think absences are bad in general, right? As a professor, I think absences probably lower test scores, but we're asking the question, maybe they're really more problematic for weaker students. Maybe it's possible that absences has no impact on test scores for stronger students, and it only has impacts for weaker students. Or maybe it impacts both stronger and weaker students, but it impacts weaker students more. And that's what we're talking about here, looking at subgroups, running our regression, and then comparing. So if my goal is to make a comparison like this, then it requires two subgroups. In this case, I could have more, but we're keeping it simple for now. So in the example I just talked about with number of absences and test scores, in this case, if I want to know if absences affect stronger and weaker students similarly, I need those two subgroups. So I need to have my data divided into stronger and weaker college students, assuming that I've got this big data set on college students. Now, in some cases, I might need to define if it's not obvious. And if I'm talking about stronger and weaker college students, it's not obvious to me what I mean by that. So maybe I have to define in some way, and let's just say I define econ majors with GPAs being less than 2.5 as weaker students, but econ majors with GPAs of 2.5 or greater are stronger students. Now, it could be 3.0, it could be 2.0, there's different ways to slice and dice it. But if you're dividing into two groups, there needs to be some logic, and you need to be very transparent in your study about how you're dividing your populations. You certainly don't want to be accused of manipulating it, like, could I divide it in a place that gives me the results I want? I don't know. So you want to be very clear and you want to motivate. Now, sometimes a dummy variable allows for very easy division into subgroups. So maybe I'm looking at absences for econ majors versus absences and their impact on test scores for other business majors. Well, in this case, it's very easy. I don't have any decisions to make. I would just create a dummy variable, right? Econ major equals 1, give it a 0 otherwise. So that means econ majors get a 1 and other business majors will get a 0. And now I can sort my group, right? And I can divide it very easily into two different groups, right? So a dummy variable is a super easy way to define two groups. So maybe I'm looking at male, female, maybe we're looking at people who have more than 10 years seniority in my business versus less than 10 years seniority. There's all different ways to slice and dice data based on a dummy variable. All right. Now, for those who have advanced regression analysis knowledge, you're probably thinking, this doesn't seem like the optimal way to do this. And clearly there's a more sophisticated way to answer the types of questions that we're answering by creating interaction variables. So some of you who have had a lot of regression analysis, maybe you were an economics major as an undergrad, are going, yeah, okay, interaction variables. And that would be absolutely correct. That would be a way for us to do the same thing, but it's a little harder to interpret. And we did not cover this topic intentionally because it really would be quite challenging, I think, for us to get through interaction variables. So we're using an alternate method, and it's still very valid, but I appreciate that in some contexts, those of you who have the knowledge would create interactions. So let's not worry about the idea of interactions. But here, we're going to use another way that's going to make it very simple. And again, what's our goal? Make comparisons between subsamples. All right. So let's say that I'm looking at a recent project that I did with Professor Zirkle. And I'm going to thank Professor Zirkle right now because we are actually together, and I asked him to run some data really quickly and give me some regression results so I could make this video for you. So Professor Zirkle and I have been doing this big project looking at business school accreditation. And not all business schools have accreditation, right? Not all business schools are accredited. So for fun, we're going to use our data set, but we're going to do something different. This is not at all what we did in our study, but we just happen to have this data set sitting on our computers. So let's say we're looking at SAT scores of colleges and universities as our dependent variable. And we want to look at two groups of accreditation, and that's going to be how we divide our data set into two groups. All right, so we're looking at explaining SAT scores. This is not a very exciting example. I'm not even going to try to defend this model. It's just for illustration, but I have two subgroups. Now, the most exclusive type of accreditation is AACSB accreditation for business schools, and that's what Longwood has, might have factored into your decision to be in our MBA program. And then there's two less exclusive accreditations that I'm just going to flop together, ACBSP and IACBE. So that's going to be my other accreditation category. So what I can do here is then take my set of data for accredited institutions and divide them in this way. So if I take all of the accredited schools in our data set, and we have schools that aren't accredited, but I'm just looking at the accredited schools, I can create two subgroups for accreditation, AACSB and not AACSB. So if they're all accredited and you're AACSB, great, you're in one group. If you're an institution that's not AACSB, then you must have the other accreditation. So two groups we've created here, and that's going to allow me to create two regressions and compare. Now, as I've said, this model is not great. It's going to serve our purposes just fine. I'm not trying to defend this model as being a good study. This is not what we did in our research project, but we're basically mooching off the data set. All right, so Professor Zirkle threw together some results for us to take a quick look at. Now, as you see here, here's some regression results, and this is how we would present them for publishing if we were having our papers peer reviewed by other economics professors and business professors. So the layout may look a little different than what you're going to be putting together for things that you do, maybe for my class. But you see that the coefficients are reported. For example, public has a negative 124. All right, so if you're a public institution, holding all else constant, we see a statistically significant result. It lowers SAT scores for AACSB schools by 124 points. All right, in parentheses, we've got our standard errors. You notice the asterisk system that we're using in my class. So 3 stars, look at the legend under the table, which we're going to be using, suggests that we are significant at the 99.9% level. But also notice at the bottom of the table, we've reported observations. We have 166 observations for AACSB institutions. We have 80 for institutions with the other accreditation. Now, it's important for us to report the number of observations because that's important. What is the proportion of the split in your subgroups? You also see that I've reported the R-squares there, and they're a bit different. Not going to worry about that, but you do have to report that stuff. All right, now, it's also important that you be clear what is in each column. So notice that I've called these Model 1 and Model 1A and Model 1B, and by doing that, it suggests that these are both versions of Model 1, and I'm just looking at two different subgroups, and I'm clear, AACSB and other accreditation. Of course, in the text, in the discussion, we are going to be clear about the subgroups, right? So if you're asked to do something like this in a project, you're going to want to be very clear how you've divided this. So don't have the reader try to figure out, okay, wait a minute, you divided into two subgroups. Now, why did you do that? You should have already been talking about that. Okay, so let's take a look at some comparisons. Now, we took the natural log of age of institutions to give it a nonlinearity. Do not worry about that at all. We're not caring so much about the interpretation. This is just an illustration. But look at this variable that I have in red, that's outlined in red. We've got this variable of age of the institution. And we see for the first column, highly significant, right? 3 stars. Second column, no stars. So what that's telling us is that age is significant in the subset of for AACSB schools. But if we look at the schools with other accreditation, age of the institution does not seem to have a statistical impact on our dependent variable, remember, which is SAT. So this is a different situation. I've got two very different results for the same explanatory variable, two different results for the two different subgroups. So that's interesting. So make sure that you're pointing out those kinds of things if you're making comparisons. So in this case, I would definitely want to say, look, for Model 1B, for other accreditations on the right in orange, doesn't appear that age of the institution affects SATs. But on the left, when we look at AACSB institutions only, not only do we see that it's highly significant, it's got a pretty significantly large coefficient, right? So being AACSB has a highly statistically significant result. I'm not going to talk about interpreting that because this is a natural log variable. We didn't deal with natural logs, so let's not bother there. But do you see what I'm going at? That this is pretty cool because side by side, I can make a comparison. Let's look at another one. Acceptance rate. Well, we see something different between the two models, A and B. When we're looking at AACSB schools only, we see a result that's significant at the 0.05 level. Acceptance rates affects SAT scores. Now, if you look at the other subgroup, those with the alternate accreditation, it doesn't seem to have a statistically significant impact. So we have something different there as well. Then let's look at public. So is it a public institution? The impact of being a public institution is highly significant in both our subset of AACSB schools and our schools with the other accreditation, right? Both are negative, right? So public schools decrease SAT scores, holding all else constant. They're both significant at the 99% level. But what we do see is that the magnitude differs, right? On the left, you see a bigger impact in terms of the size, 124-point decrease in SAT scores, versus the schools with the other accreditation, it's a decrease of 90. Both have the same type of effect. Being a public school relative to what? A private school decreases SAT scores by 124 points for the left, 90 points in the right. All right. So guys, what I'm showing you here is called stratification. That's a fancy name for creating subgroups. We have stratified the data into subgroups. So if you want to use that language, it would be perfectly appropriate. So if you're doing a regression and you divide males versus females, or business majors versus non-business majors, or athletes versus non-athletes, or upper level management, lower level management, whatever you're doing, you have stratified the data if you're creating a regression for each category. So in this case, we have two subgroups, but there could be more. It depends on what your question is, right? It could be that you have three groups. It doesn't always have to be two. In a dummy variable situation, it would likely be two, but I have three groups actually in my data set here with Professor Zirkle. We have schools that are AACSB accredited. We have schools that have the other alternate accreditation. And then we have some that choose not to get any accreditation at all. And so I could have three groups, and I'm going to show you that in a second, but I do want to warn you to be careful not to over stratify. You don't want to create so many subgroups that you have a very, very small N. And if you have two subgroups, but they are divided out where one has a teeny tiny N, that's probably not going to be very good. Like if I looked at business majors who are domestic versus international students, I'm going to end up with so few international students. I mean, I can do it, but I'm running a regression on just a handful of observations in that case. That's probably not so legitimate. So here's my results if I use all three categories, and I'm not going to go through this, but what you see, look at number of observations. I have 166 for Model 1A, Model 1B. If I was going to do anything with this, I should really relabel this and call this Model 1C in green, but I'm not going to do anything with it. So I have 166, 80, 123. Those are all pretty good size N's, but if the one in green had been like 4 or 5, gosh, that'd be really horrible. I don't want to have a subgroup with that few. Now, before we wrap up, I just want to eliminate one potential point of confusion, and that stratification is different from just having a dummy or categorical variable in your model. So let's say that I run a model and I just put in a dummy variable for AACSB accreditation, where my omitted category is the other accreditation. And that's fine, you can do that. But here's the thing. That's going to help us differentiate between AACSB and those other accreditations, but only in terms of the impact on our dependent variable, right? When we put a dummy variable in like male, I want to know if males have higher test scores. I want to know if males are paid more. I want to know if married people are paid more, have higher salaries than not married people, right? All of those are examples of putting in a dummy variable, but that only tells us if it makes our dependent variable go up or down. But that's not what I just did, right? I looked at a whole bunch of variables, right? So if I want to know, does AACSB make our dependent variable increase or decrease, our SAT score, for example, increase or decrease relative to the omitted category, I can just throw in a dummy variable. But again, that's not what I did. I wasn't looking at just the impact of AACSB on our dependent variable SAT score. When I stratified, we can look at all of the explanatory variables, right? I looked at age. I looked at, now I can't even remember what I looked at, but I have a variable for MBA. I can look at whether public has an impact that's different between the two. So what I can do with stratification is different than just putting in a dummy variable into my model. So understand that what we're doing here is creating two different regressions and then comparing them. And then I can look at how coefficients and significance differ for the two groups, right? And I can do a little bit more with stratification than I can with a simple dummy variable. But remember, we could do it really sophisticatedly in one model. There is a way to do it in one model with interactions, but we don't know how to do it. All right, so to wrap up, this isn't necessarily the sexiest way to do a comparison. Interaction variables are really cool. I like them. They're just a little sophisticated for us to worry about in this class. And so with Professor Zirkel and I, we did a lot of research together. Our approach might change based on who our audience is. Sometimes we publish for audiences that don't understand the interaction variables quite as well, and so maybe stratification makes more sense. But this approach of stratification allows us to make interesting conclusions, right? It allows us to compare explanatory variable by explanatory variable, right? Does the effect of public differ between their two subsamples? Does age of the institution change in terms of its impact on SAT score when we look at our two different groups? We have some very similar results for subgroups, as you saw. Some things didn't change at all. They were either significant and highly significant for both, or maybe they were insignificant for both. That was certainly the case for a lot of those variables. And then we had some results that differed. Remember, they differed in either the magnitude of the coefficient, maybe they were both highly significant, but the magnitude of the coefficient differed, or they were different because one was much more highly significant than the other. Either way, we need to be precise in what we're concluding when we are making comparisons. So as always, you want to make sure you're being accurate and being very precise as you write up your results. So if you have any questions, let me know. And I hope you guys have a fantastic day.